In this lesson, we'll look at some graphs of polynomials. In the first set, we have x minus 1 to power 2. We have x plus 2 to power 2. And then another even power, we have x minus 1 to power 4, x plus 2 to power 4, x minus 3 to power 6. So let's look at what these look like. The first one, x minus 1 to power 2. We have an x-intercept of 1 here. In the second one, we have x plus 2 to power 2, and we get an x-intercept of minus 2 from that one. In this one, we have x minus 1 to power 4, and that's in green. That's here. And notice all of these graphs are opening upwards. They're up graphs. And we have x plus 2 to power 4 here. So it's looking a little narrower at the top than the other one, but the x-intercept is minus 2. This one, we can tell the x-intercept is going to be 3, and it's power 6, so I'm predicting this is going to be an up graph, and there it is here. So this is x minus 3 to power 6 here. Notice in each of these graphs, they are coming down to the x-intercept, touching the x-intercept, and then going up. And they're all doing that. That is because we have even powers in the polynomial. We have 2 here, we have 4, and then we have 6 for this one. They are opening up because each polynomial is positive in each case here. In the next set of polynomials, the power is an odd number. Notice we have 3 here, we have 5, and we have 7. So let's see what happens to these. For x minus 1 cubed, we have an x-intercepted 1. But notice now the graph is cutting the x-axis, okay? And that is because we have an odd power here. Let's look at the next one. So x plus 3 cubed, we have a repeated root at minus 3 here. And because we have an odd power, again, the graph is cutting the x-axis. Now we have power 5, which is an odd power. And the same way, the graph will cut at the x-intercept, which is 2, and pass through the x-axis like that. And power 7, x plus 5 power 7. We have an x-intercept at minus 5, and the graph is passing through the x-axis at the x-intercept here. So in each case, the graph is cutting the x-axis, and that is because these powers are odd. In the next set of graphs, we've mixed up the factors. So now we have x minus 1, x plus 3, x minus 2. Notice that the power on each factor is an odd number, it's 1. Okay, so I'm predicting that at each x-intercept, the graph will cut the x-axis. Let's have a look. Okay, so x minus 1, the x-intercept here is 1. That's here. X plus 3, so the x-intercept will be minus 3. That's here. And x minus 2, the x-intercept will be 2. Okay, and notice now that because we're using odd power on each factor is to power 1, then the graph is cutting through the x-axis in each case. In this example, we have x minus 2 to power 2 and x plus 3. So this is a cubic polynomial. And we have an even power here, power 2. And here we have an odd power, which is power 1. Let's draw it. Okay, So at x minus 2, we have an even power. So the graph is touching the x-intercept at 2, then going up. It's not cutting the graph. So this is even power. And that was power 2 on the polynomial here. But this is power 1. So at x equals minus 3, we have an odd power, power 1. So the graph is cutting through. So that's odd power on the factor. In the third example, we have x minus 1 squared times x plus 1 squared. Now this would be x to power 4 if we expand this, so it's in the x squared family. And x to power 4 means it's a quartic graph. Let's take a look. Okay, so we have both even powers, which means that your graph is not going to pass through the x-axis. And that's what happens here. So at 2, which comes from this factor here, we will touch the x-axis and pass up. We go up to this point, then down to minus 1, and that's your x-intercept from this factor here. And because we have even powers, the graph is touching the x-axis, but it's not passing through it. And that's because we have even powers here. In the next example, we have x minus 1 to power 1, so that's an odd power. And we have x plus 2 to power 2. So let's see what that looks like. So we have x minus 1 giving us this x-intercept of 1. And because the power is odd, we cut through that point. But here we have power 2. So at x equals minus 2, we will not cut. We will touch the x-axis and then go down. In the last example, we have x minus 2 power 2, x plus 1 to power 2. These are both even powers. And x minus 1 to power 1, which is an odd power. If you expanded this, you're going to get x2 times x2 times x. So this will be x power 5, which puts it in the x cubed family. So let's have a look. Okay, so x minus 2 power 2. So, and this one is x plus 1 power 2. So these will touch the graph, but not cut. So at 2, you can see we are touching the graph, but we're not passing through 2. We'll go up. Through 1, we cut the graph because of the odd power, x minus 1 to power 1. Then we'll go down and back up. At x plus 1 squared, we will touch the x-axis and then go back down to negative infinity. So that's just a summary of some different kinds of polynomials you're going to come across. And this will help you to understand about the effect of the powers that you have on each factor here. So if you have an odd power, your graph is going to cut through that x-intercept. But you have an even power like 6 or 4 or 2, then you'll have this situation where the graph will touch the x-intercept and then go down in the same direction that it came from.